Whenever a student makes a mistake, something has mixed them up. There's something they didn't understand, or something that the language was confusing to them, or something. And it really helps to think not just, that's not right, here's what's right, but I think it's a fascinating challenge. What is it that you were thinking that caused this mistake? And because if you can address that, you really explain to them very well, instead of just repeating what's correct. One thing that happens, I think, is that people sometimes have difficulty with the language in ways that teachers don't always kind of realize. And I'm going to give you an example. Okay, so let's say that students were doing a set of problems and they had to round to the nearest hundredths place, which is the second place to the right of the decimal. This becomes 0.46 rounded to the nearest hundredths, and this becomes 0.53 rounded to the nearest hundredths. Because this is bigger than 5, it's closer to the higher number in the hundredths place. Because this is less than 5, it's closer to the lower one. Now, I have seen people do this. They have, on this one, instead of 0.46, they give the answer as 0.45. Do you have any idea why they're doing that? After teaching this for a while, it hit me what was confusing them. Here we're rounding down, and here we're rounding up. That's your clue. Can you think of why they have changed this to 0.45? Give you a second to think. When we round up, we are raising the number that we are rounding to, the hundredths place, because the closest, the hundredths place with the closest value to this raises the number by 1. The number that's the closest value to this keeps the 6. But if they think of rounding up as raising a number, students might hear rounding down as lowering a number. And instead of putting 0.46, they would put 0.45. So this is actually a language, the language that we use when we teach rounding off. Rounding up or rounding down is, I think, what's responsible for students making this mistake, and I've seen this a few times. And it kind of finally hit me why they were doing this. So always, it's good to try and figure out, not, well, they've done it wrong and here's what's correct, but what were they thinking to have done it the way that they did? Because when you can understand that and address it, they will really understand. Another example is, I've had students solve an equation in one unknown and then go back and I say, okay, check your solution, and they might have a couple of x's, terms with x, an x and an x squared or whatever it is. And they say if x equals 2. So they put a 2 in for the x, and then they say, what's the other x equal to? And you think, you just solved the problem, the answer is 2. But I think the reason that they're doing that is we call the x a variable. And so I think that they perhaps have the concept that x can vary. So you kind of have to explain it varies from problem to problem if you've got a letter, a variable in there, but it doesn't vary within one problem. When we solve a problem for x, whatever we get is what x equals every time we encounter it in that one problem. If a student understands the meaning behind what they're doing, they don't forget that often. So if you have a student multiplying or adding, and they forget that this is the way we add, and to multiply, we multiply this as 2/9. If the student says this is equal to 3/9 or something like 3/3, they're mixing the operations that we do in adding and multiplying. then they really didn't understand what the meaning of a fraction is and what it means to add fractions. If they take this and they say it's 3/6, they can't understand that it's 2 of a thing called thirds and another of a thing called thirds, making 3 of those thirds altogether. So I always recommend, whenever you're giving a formula, you really, as a teacher, you've got to make sure you understand why the formula is what it is and what it means, so that you can explain that to the students. Because when they understand what the formula means and signifies, then they're much less likely to mix it up with some other formula or mix the algorithms that they do when they're adding or multiplying fractions or whatever. So when students tell me they forget, in my mind, what they've just told me is, I never really understood it that well. And it needs to be re-explained so I understand what's going on better. And my last tip is very important. A lot of times when students are learning things, they get a page of something like adding fractions, a page, another day they'll do a page of percentages, another page they'll do a page of multiplying fractions or whatever. And then when it comes time to do a chapter review, they can't remember which procedure goes to which, and they're confused on how to do each of these problems. It is extremely important that students always be mixing the kind of problem they do. And this applies in other things as well. When students are learning spelling words, if they have to only remember their 20 spelling words, and then a semester later they get a semester exam, they have to go back and study them all, they will have forgotten a lot of them. Some of them you may double the final letter and add something at the end, an ED, and some of them you don't. They won't remember which is which. So we tend to teach in an organized fashion. Everything where you double the final letter, everything where you whatever. The best way to make sure students are not forgetting and are integrating what they know with what they already know is to make tests cumulative. Yes, it's more difficult for the students, but it's the only way to tell if they really understand what they're doing. So spelling tests, definitely mathematics tests. Mix in a few problems from previous chapters of different procedures so that they aren't forgetting and they can distinguish between what they've just learned versus the algorithm of the process for what they learned last week. And so, and I even think at the end of a class, show them very quickly what they're going to learn in the next class. Just a problem, or even, it can be no more than 15 seconds. You would be amazed how much of a difference that makes in enabling them to grasp it the next time you introduce it. It makes a huge difference because concepts take time to settle in the mind. And if you give them the next 24 hours or a week or whatever it is, the lag time, before you then come back to that concept, they have it introduced a little bit. They've kind of got a little bit of, they've done a little bit of the work of assimilating the meaning in their own minds of that material. And so you're doing what is, to some extent, a little bit of a review, and they'll pick it up much faster.